Congratulations on finishing Chapter 2. We're going to start Chapter 3 today and discuss some more definitions and properties and such. Today we're going to focus on the properties of parallel lines. So before we do that, the first thing I want you to know is what a transversal is. A transversal is a line that intersects two or more lines at different points. Okay? And it's called a transversal to the given line. So this line P right here is a transversal to line L and line M. Now when you have a transversal, it forms lots of different angles, and some of these angles have special names, and you're going to need to know what they are. One of them are alternate interior angles. And just think about these words. Interior means on the inside. So these are angles that are found on the inside of the two parallel lines, or the two lines that are cut by a transversal, and they alternate. So this X over here is on the interior, and it's alternate over here on the bottom side, but on the inside of the two lines. Over here, the two Y's are alternate interior angles. They're on the inside and they alternate. Over here, we've got an example. Here we've got two lines that are cut by a transversal, and there are angles in the middle here on the same side, and they're called same side interior angles. They're on the inside the lines, and they're on the same side of this transversal. We could also have one over here and over here on the left, and they would also be same side interior angles. We can also have what's called corresponding angles, and corresponding angles are angles that are formed that correspond with this line and this line, the two different lines that are cut by this transversal. So such A equals E. These two are corresponding angles, A and E. And then if you look at C and G, they are also corresponding angles. They fall on the same part of the line that's being cut by the transversal. B and F are corresponding angles, and D and H are corresponding angles. So yes, you'll need to know what a transversal is. You'll need to know what alternate interior angles are, same side interior angles, and corresponding angles. Now, some of them have postulates and things that are true about them. So the first one is postulate 3.1. It deals with corresponding angles. That's these up here, ones that are found on the same side in the same area of both the lines that are cut by the transversal. If a transversal intersects two parallel lines, now this is where your parallel comes into play. If a transversal intersects two parallel lines, line L and line M are parallel, then the corresponding angles are congruent. That means angle 1 is congruent to angle 2. If this angle right here had a number 3 and this one had a number 4, number 3 and number 4 would be congruent because they're corresponding angles. So with this angle up here with this angle down here, they would be congruent because of this postulate. And as well, this angle, vertical angle from 1, this one right here, would be congruent to this one down here. Hopefully you can follow my marker pen where I'm pointing. That's the corresponding angles postulate. There is also the alternate interior angles theorem. Those are the ones that we talked about right here that kind of are on opposite sides of this transversal, but they're on the inside of it. That's why they're interior. This one says if a transversal intersects two parallel lines, then the alternate interior angles are also congruent. So in this picture, angle 1 is congruent to angle 2. And if this little space right here had a 3 and that space had a 4, angle 3 and angle 4 would be congruent as well because of the alternate interior angles theorem. Some properties of parallel lines. This is the same side interior angles theorem. That's this one right here. These are same side interior angles. If a transversal intersects two parallel lines, there's our important part again, two parallel lines cut by a transversal, the same side interior angles are supplementary. That means angle 2 and angle 1, when you add up their measurement, equal 180. Be the same for these, or not these two. No, these two would not. These are not parallel lines, but these two are. So you do need to know that they are parallel lines. So we need to know these, know where to find them if you need to use them to prove something. Down here, I've shown you what a proof is hopefully going to look like. This is called a two-column proof. You'll be writing what you are given, such as L. This line L is parallel to line M, so you're told that. And then what you're asked to prove. You're asked to prove that angle 2 is congruent to angle 7. So this is the stuff that you know. This is what you need to show. So this is your two columns where the two-column proof comes into play. You'll have statements, and then you've got to give your reasons. This is your justification part. Tell me why. How do you know that this is true? So for instance, when you write this proof, angle L is parallel to angle M. Well, that's given to you right there. You're already told that. Your next step you should show, because your goal is to show that angle 2 is congruent to angle 7. Your next step would be angle 2 is congruent to angle 6. How do you know that? Well, you have something up here that says when two parallel lines are cut by a transversal, that's what this line means right here, your corresponding angles are congruent. That's what we learned right up here in this corresponding angle postulate. So you can say that angle 2 and angle 6 are congruent. The next thing you can say is that angle 6 is congruent to angle 7 because vertical angles are congruent, and these two are vertical angles. And because of that, you can now say that angle 2 is congruent to angle 7. That's what we've been asked to prove. And that is simply the transitive property of congruency, because 2 is congruent to 6, 6 is congruent to 7, so 2 has to be congruent to 7. So I want you to practice writing this. This is what a two-column proof is going to look like. Nice and neat, showing me what's given, what you're going to prove, your statements, and your reasons. This is another example of a two-column proof. This is proving that alternate interior angles theorem. You're going to prove that. So you're given that P, line P, is parallel, that's what this means right here, to line Q. You need to prove that angle 1 is congruent to angle 2. So the first thing you're always going to write is what you're told, what you're given already, that P, in this case, it's that P is parallel to Q. That's given. And because of that, you can say, well, angle 1 is congruent to angle 3 because that's your corresponding angles postulate right there. Then you're able to say, well, angle 3 is congruent to angle 2 because of the vertical angles theorem. And now using your transitive property, you're able to say, of congruency, you're able to say that angle 1 is congruent to angle 2. So I do want you to write this down to get practice in writing that two-column proof. Here, you're going to have to figure out some angle measurements based on all of these theorems and postulates and definitions that we talked about up here. I've already worked them out for you, and this is just as an example because you'll be asked to do some yourself. If you're told that WX is parallel to YZ, you can see that it's cut by a transversal. If the measure of angle 3, right here, is 150, what's the measure of angle 1? Well, how did I figure out that it was 30? I knew that this right here had to make 180 degrees because that's a straight line. So I can figure out that angle 2 is 30 degrees. Well, angle 2 is congruent to angle 1 because of the corresponding angles are congruent. And then, thus, I was able to figure out that angle 1 is 30 degrees. Down here, I am told that line L is parallel to line M. You can see that it's cut by a transversal. And you're asked to identify the value of x. I know that x plus 5 is going to equal 100 because corresponding angles are congruent. So if I set x plus 5 plus whatever, or I know that this is, I'm sorry that this is 100. I'm getting ahead of myself. So if I set this equal to 100, x has to be 95 because of the corresponding angles. Lastly, I put this picture up here, and it says in this diagram below, you're told that PQ is parallel to ST, and you're asked to find the measure of this angle. Well, how did I go about this? Well, I know that right here, this angle QRT, it has the value of x, and I know that SRT is x plus 50. I know that this one and this one together make 180 because that's a straight line. So I set x plus 50 because those are my values here equal to 180, and I found that x equals 65. So if x equals 65, well, x plus 50 is 115. Then I also know that two parallel lines cut by a transversal, that the alternate interior angles are congruent. And up here I'm told that this angle is 40. So down here, angle RST has to equal 40. And since I know this angle is 115 and this angle is 40, I'm able to figure out T as being 25 because all the angles of a triangle add up to be 180. So when I put 115 and 40 together and I took it away from 180, I was left with 25. So you will see some problems like this in the future where you have to use all of your information to figure out different angle values. No, that's not going to work. I just thought I'd put that in there for fun. So we'll be using all this coming up very soon. Thank you very much.